Okay, hello friends. My name is Christopher George Kakoko. I'm doing my bachelor degree in science, actually in maths, majorly in maths, mainly in physics. So I'm studying in front of you today to make my points under mathematics. I saw a lot of people failing maths in GCE because they don't have a lot of information about maths. So I'm making this video, I'm planning to make a lot of videos, but I've started with this one. This is my first video. So what I want you guys is to help me to like my videos, you share my videos, even to comment my videos. At the end of the day, we'll try to help one another. And I also have a WhatsApp group for both GCEs and grade 12s. I will make you 100%. With all my heart, you will be successful in maths. Thank you. Hello friends. Today we are going to look at how to prove the quadratic equation. How to prove the quadratic equations. Now, when you want to prove the quadratic equations, we normally use the method which we call the completing the square method. Now, you may be wondering that what's the quadratic equation? What's the format of the quadratic equations? I'm sure all the grade 12s, they normally know that the quadratic equation is equal to x is equal to negative b, positive or negative, the root of b squared minus 4ac upon 2a. Now, they normally fail to answer questions which deals with the quadratic equations. The reason is very simple. I came to find out that most of them, they normally forget to view this formula when they are writing exam because they don't know where it is coming from. This equation, we normally use it when we're answering questions like 3x squared plus 2x minus 1 is equal to 0. This is one of the examples of the quadratic equation. I can even give another one. Or we can say that 3 over 2x squared plus x is equal to 0. These are examples of the quadratic equations, whereby 3 is the value of m, 2 is the value for b, and negative 1 is the value of a constant. That's why we normally use these equations. Now, this time I'm teaching you friends where to derive this quadratic equation. Where is it coming from? By the process of completing the square method. So now we all know that the quadratic equation is given by the general formula ax squared plus bx plus c is equal to 0. This is the general quadratic equation where we normally derive the quadratic equation formula. Now, what's the procedure? What's the first step? Now, the first step you need to know is that you can't solve a completing square method when the value of a is greater than 1. For example, if the question is maybe 4x squared plus x minus 1 is equal to 0, you can't just start solving the square root minus removing this coefficient here. We normally solve it when the question is in this format. For example, I'm trying to solve the completing the square method. You divide the entire equation by 4. The reason is that we need to have the coefficient of 1. So even when proving the quadratic equation, we'll do the same thing. We'll try to divide throughout by a so that we can get rid of this a. Now let's try to do it. We have ax squared plus bx plus c is equals to 0. Now let's concentrate about the a value, the coefficient of a. Now, how do you divide? You just divide it. Let's see. This is a upon m, b upon m, and c upon a is equals to 0 upon a. Now, we are just trying to divide throughout by a so that we can get rid of this a. Now, upon dividing, you find that this a and this a will go, which will result on this equation, which is x squared plus b upon ax plus c upon a is equals to 0. Since we know that 0 divided by anything is 0. Now when you are done with step 1, what would be the second step? The second step, you know that a square is not a constant because we have x here. We also have b upon ax is not a constant because we have x. Now we need to concentrate on this part which we call the constant. We need to correct the right terms. We know that a upon c upon a is a constant value. Even 0 is a constant value. So we need to correct the right terms. How do you correct the right terms? If you are going to shift this one, which you normally say that if a positive sign cross the other side, it will be a negative sign. So that's the second thing we need to do. So if we correct the right terms, we find that we have this equation x squared plus b over ax is equals to 0 minus c over a. Now we are having a negative sign because of it was a positive sign. It has gone the other side. Okay, as simple as that. Now we know that when you subtract 0 minus anything, it will give us the same thing. 0 doesn't change anything. So we have b upon x is equals to 0 minus c upon a will give us negative c upon a. Now when you reach at this stage, it's not even difficult. That's when you apply the completing the square rule, which says that you need to add both sides of the equation. We have the left hand side and the right hand side. So you need to add, what are we adding when we reach here? You need to add both sides 1 over 2 b squared. So I'll add both sides. There's nothing I'm doing. If I add both sides, it's just the same thing. Okay. So now let's move at this step. We have x squared plus b over ax. Now we have said that we need to add, I've said that we need to add 1 over b squared both sides, so which means, let's try to add it. We'll add 1 over b squared both sides, just like that. Then is equals to, we have negative c over a. We have negative c over a. So we have negative c over a. Then again, I'll add both sides. That's what we are saying, which is 1 over 2b squared. Just like that. I can cancel them. I can come back to the original equation which we are having. There is nothing we are doing. So now, the question you should ask yourself is that, what is the meaning of this being? What is the meaning of this being? Now, the meaning of this being, if you try to see this equation the way it is, the value of a, you have a constant at this point. The value of b, you have this set which is here. That's the value of b. So our value of b is b upon a. This is the value of a as a constant value. You don't need to get confused. You can see it very nicely when we are solving using numbers. So now we know that in this case our value of b is b upon a. So where is b, I'm going to substitute with what? With b upon a. So let's try to see what we're going to have. So we have x squared plus b upon ax plus 1 over 2 times b over a. I'm substituting this fellow where is b, so that I can get b over a, which is equals to negative c over a plus the same thing. Even here I'll substitute where there is b, I'll substitute b over a. Okay, so now when we reach at this point, we just need to concentrate the things which are inside the brackets. We multiply them, we see what we have. So we have x squared plus b over ax plus 1 times b to give us b over 2a squared is equals to negative c over a plus. So it's the same thing. 1 times b to be b over 2a squared. Now when we reach at this point, I normally tell my pupils that you only need to concentrate where there is a square here. We have the x squared. We also have the b over 2a squared. So you need to concentrate when you reach at this point. You only need to concentrate these 2 points. Now why I'm saying this is that the next step we are going to do, we are going to say this thing is the same thing if you say x plus b over 2a all square, which will be equals to negative a over c, negative c over a plus what? The same thing, b over 2a square. Now people normally get confused. Why do you say that when you reach at this point, you need to deviate to this point? It's just a simple concept which normally comes. Let me show you here so that we can move together. This point is the same thing when you are dealing with the difference of 2 squares. So if we have, check this point which is here, if we have a plus b square, it's the same thing we are having a plus b again. It's the same thing. Since this square means you have 2 things which are the same, that's the way I've written them like this. So now what's the meaning of this? We can multiply them. Now if we multiply them, we get that a times a, we are getting a square plus. What is b times a? We are going to find that a times b, it is the same thing as ab plus. Again we do the same thing. B times a, we are going to get ba plus b times b, we are going to get b square like that. So now when you reach at this point, you are going to find that we have a square here, even here we have what? B square. Now these things which you are having at the middle, they are the same. In multiplication, where even if you say a times b or b times a, the answer will be the same, so they will give you the same answer. So these things at the middle, you can add them to get 2ab plus b square. Now at this stage, it's the same thing we had reached here. You will notice one thing, that the first variable, it will have a square. For example, at this point, you are having x squared, and at this point you are having b over 2a squared. So what does it mean? It means that you have the same thing as a square, then you have what? B square. So you have 2 points where you have a square and b square. So when changing this format, you can write it like you just pick a plus the other one b over, you say a plus b square. This thing will be the same meaning as this one. So that's why I was saying that when you reach at this point, you just do the same thing. You see x squared here and you see b over 2a squared. So you just concentrate where there are squares, then you write them in this format with 1 square. Now you don't need to tamper with anything to your right hand side. So that's the way we go when we reach at that point. But you don't need to show all this process, you just need to understand it. So now, when you reach at this point, we are going to focus on the right hand side. Let's leave the right hand side. Now the right hand side we have negative c over a plus, what is b squared? We know that b squared will leave it as what? B squared like that. Then what is 2a squared? The answer will give us 4a squared. So now when we reach at that point, I can love these ones. Okay, so we are trying to prove the quadratic equation. It's looking a very long process, but I'm trying to explain each and every step. So our left hand side we have, let's see, we have x plus b over 2a square is equals to negative c over a plus b square over 4a square. Now what we are going to do now, on the left hand side we leave it like that. Now on the right hand side we are going to find the common denominator. You can all agree with me that The common denominator of a and 4a squared will just be 4a squared, because a can enter into 4a squared and 4a squared can enter into itself. So the common denominator between the two will say 4a squared. So let's do this. What is a into 4a squared? You'll notice one thing. We have two a's, we have one a's, they will cancel, so we'll have just 4a. Then this 4a will multiply with negative c, where we'll have 4ac plus 4a squared divided by 4a squared is 1. 1 times b squared, the answer is just simple. We'll have b squared, just like that. Now you know that a positive sign is bigger than a negative sign, or a positive number is bigger than a negative number. So we have noticed one thing, this negative 4ac is a negative number which is smaller than positive b, but it is in flat. So there's nothing wrong when you swap them. You start with positive b squared, then you end with negative 4ac. These two guys, they have the same meaning. I'm just swapping them. Now let's see where we go now. When we reach at this stage, we are going to remove this square root. How do you remove this square root? You introduce the square root both sides of the equation, because we want to get rid of this square root here. So now how do you get rid of this square root? You introduce both sides, then we are going to cancel this square root and the 2 will go, which we all know. Then we remain with what? X plus b over 2m, which is equals to the root of what? The root of b squared minus 4ac over 4a squared. But notice one thing, this square root is for both the numerator and the denominator. Now people get confused when they reach here. We know that in SATs, when you are dealing a topic under SATs, there is a rule which says that if you have a number which is under root and it is in a fraction form, which means it's the same thing, you write it like this, a over the root of a over the root of b. It's the same meaning, because this root is for both the numerator and the denominator, so you can separate them like this. So now when you reach at this stage, it's the same thing. This square root is for both the numerator and the denominator. So how are you going to handle it? You are going to say x is equals to x plus b over 2a is equals to the root of b squared minus 4ac over the root of 4a squared. So we have separated the root. You can see that at this stage the quadratic equation is coming into form. So now when we reach at this stage, we are going to deal with the denominator, because we have a 4 and a x squared. So now we know that the root of 4a squared in SAT is the same thing. We write it as the root of 4 times the root of a squared, where you know that the root of 4 is 2 times the root of a squared is just a. You multiply them, you get the answer as what? As 2a. So you know that when the denominator, the root of 4a squared is just the same thing as 4a, so it's 2a. So we are going to remove it and substitute it with 2a. We are almost done. We are almost done how to prove the quadratic equation. So now at this point, let me just rewrite it again. We have x plus b over 2a is equals to the root of b squared minus 4ac upon, now we write 2a, because we know that the root of 4a squared is just the same thing as 2a. Now we need to leave the value of x alone, since we know that now we have only the constants. So we need to bring all the constants on the other side, on the right hand side. So we know that this positive b over 2a is a positive sign. When it goes the other side, it will become as a negative. So So now we have therefore x is equals to negative b over 2a positive or negative. Why am I writing positive or negative? We know that when you are finding the root of 4, you say positive or negative 2. That's the answer. That's why I'm saying that we know that we can see there is a root here. So the root of this thing, the answer will carry two signs, positive or negative. Then we say the root of b for a c over 2a. We can see that the quadratic equation is coming into play. Now, then what's the next thing? We know that when you are adding or subtracting fractions, you need to find the common denominator. So now let's find the common denominator. The common denominator of this set and this set, we know they are the same. So we say it is what? It is 2a. So we say that 2a into 2a is 1. 1 times b, we say it is negative b. Positive or negative. You just pick it the way it is, you place them here. Then the other thing, 2a into 2a is the same thing, it is 1. Then 1 times the root of b squared minus 4a squared, the answer will be the root of b squared